Good morning, fifth graders. Ms. Jagodnik here again with another math lesson that we are reviewing from earlier in the year. We're in the section that has been dealing with mixed numbers. Ms. Singh went over how to multiply mixed numbers with you yesterday. Today we're going to talk a little bit more of a thinking skill and not a calculating skill. So if you notice my poster, it says right toward the top, no calculating. So today we're going to be talking about rules, generalizations, patterns we can work with to help us reason through problems, check that our answers are reasonable and make sense. The lesson that we are reviewing, if you want to look back and remind yourself of when we did this in class, was lesson 8.8, which is pages 499 to 504 in your book. And the lesson is called scaling, which can mean a lot of different things, but in this case, it's just a fancy way of saying resizing. Thinking about how what you're doing affects the size of the mixed number or the fraction that you're working with. So really what we're talking about is coming up with patterns of when can I expect my answer to be bigger than what I started with, less than what I started with, or the same as what I started with. So in this first couple of problems that we're going to review, and they're in your book at the end of the section review sets, but we don't really need to worry about following along in your book, because we're just going to look through them and think through them here. So these first few problems are just asking you to say exactly that. Think about what you're starting with, and is my product, once I multiply, going to be greater than, less than, or equal to? So looking at the first example, here's my expression, 2 1/10 times 3/5. And what I want to know is I want to be able to compare my product to 2 1/10. The number I started with. So once I take that number and I multiply it by 3/5, I want to know, am I going to get a bigger answer? Should I get a smaller answer? Or should I still have 2 1/10? Okay. So let's talk about the meaning of multiplication and some patterns we can think about. If I am multiplying by 3/5, that means I'm multiplying by something less than 1, right? This is a regular fraction. It means I've taken a whole, divided it into 5 parts, and I'm not taking all 5 of them, I'm only taking 3 of them. So part of what I started with. So because that's the case, and that's what this means, anything times a fraction that is less than 1 is going to end up with a product less than what I started with. Let's say I have 2 1/10 apples. When I multiply times 3/5, I'm saying I don't want all of my 2 1/10 apples. I only want 3/5 of them. So I'm going to take what I have, I'm going to separate it into 5 groups, and I'm going to take 3 of those groups and leave the other 2 where they were. So obviously my answer is going to be less than what I started with because I'm only taking part of what I started with. So there's the generalization for you. If I have any kind of number, I multiply by something that is less than 1, whether it's a fraction, decimal, it's less than 1, then I get a smaller product. So this right here is less than 1 whole. That means my answer is going to be less than 2 1/10. Okay. My answer is going to be smaller. So whatever this answer is, it's going to be smaller than what I started with. Okay. Now if I look at number 2, okay, I'm taking 3/4 times 5/5, and I want to know if my answer is going to be greater than, less than, or equal to 3/4. You should be noticing something right away about 5/5. 5/5 has the same numerator and denominator. And as we know from all our fraction work, if the numerator and denominator are the same, that means it is equivalent to 1 whole. So I know that this is equal to 1. And we should know from years of multiplication practice at this point that anything times 1 is itself. It's equal to what I started with. Okay, so I'm just going to put an equal sign in here. If I have any fraction equivalent to 1, 5/5, 10/10, 34 over 34, 5,263 over 5,263. If the numerator and the denominator are the same, it's equal to 1. I know anything times 1, my answer does not change, it stays the same. So that's going to be the same even when I'm working with fractions or mixed numbers. Here's my third problem. Okay, now you're starting to see we've tried out all the different kinds now. This time I'm taking my 7.5 and I'm multiplying by 1 1/6. So that is greater than 1. So what does this really mean? It means I'm starting with 7.5 of something, and I want to multiply it times 1 1/6, which means I want more of it. If I'm doing 1 1/6 times something, that means that times 1 would be the whole thing that I started with plus an extra 1/6 of it. So it's 1 and a little bit extra. So even though it's only a little bit more than 1 whole, if I multiply something times anything greater than 1, my answer is going to end up being bigger than what I started with. So this is just a recap summary here, generalizations so that you can burn them into your brain and remember them, because that's all you need to ace this chapter. If I'm multiplying my number by something greater than 1, my answer is going to be greater. If I'm multiplying my number by something equal to 1, my answer is going to stay the same. And if I'm multiplying my number by something less than 1, my answer is going to get less. That's all I'm looking for here. Okay. Now let's look over here. Here I have 8/3, and I'm multiplying times 9/10. So based on our generalizations, all I have to ask myself is 9/10 less than 1, equal to 1, or greater than 1? Because 9/10, it's not 1 whole yet, it's not 10/10, it's a fraction less than 1. My numerator is less than my denominator. So I know it's less than 1, which means my answer is going to be less than what I started with. I am multiplying by something less than 1, I'm getting smaller, that's all. All right, if we look at our next few problems to work on, now we're just adding another little step to it. Instead of comparing two things, I am now getting lists of 3 expressions, and I have to put them in order from least to greatest. So I'm looking for the smallest one first, and then I'm going to do middle and big. So I want to look at what I have here. I notice all of them have 3 1/5 in common. I'm just practicing this skill up here and asking myself, what's it being multiplied by? I notice that this is being multiplied by 9/10, so that's less than 1. This is being multiplied by 1.5, so that's greater than 1. And this is just by itself, so it's like times 1, that's fine, it's just going to stay the same. So again, using my generalization, if I'm taking my 3 1/5 and multiplying by a fraction less than 1, my answer is going to get smaller. So this 3 1/5 times 9/10 must be the smallest of the 3, because my answer is not even going to be 3 1/5. It's only going to be 9/10 of that. Then my middle one is going to be 3 1/5, because that's just by itself, like times 1. And then my greatest one is going to be the 3 1/5 times 1/2, because that's going to be bigger than what I started with, because I'm not only taking the whole 3 1/5, but then I'm taking another half of it on top of that. All right, same thing down here. First, I'm going to look at my list. What do they have in common? 2/3, 2/3, 2/3. This is being multiplied by something less than 1, so it's going to be the smallest. This is an improper fraction, just so it's kind of like 1 1/4, so it's going to be greater than 1, and that's by itself. So once again, if I'm multiplying 2/3 times something less than 1, that's going to be the smallest result. 2/3 by itself is going to be in the middle, and then 2/3 times something greater than 1, 5/4, is going to be the biggest product. Notice here, this 3/4 is actually a bigger fraction than 2/3, but that's not what we're comparing. When we're talking about less than or greater than in these generalizations, it doesn't matter if what I'm multiplying by is less than or greater than the number I started with. All that matters is it less than or greater than 1? So don't get mixed up with those two things. Okay, final problem we're going to go over. I see that I have 2 and 1/3 in all of them. This one is times 5 over 5, so I know that's equal to 1. This one has 6/5. That's an improper fraction, so I know it's greater than 1. And this one has 1/5. That's a regular old fraction, so it's less than 1. So this is going to be my smallest product, 2 and 1/3 times 1/5. I'm only taking 1/5 of what I started with, leaving the rest alone. This one is going to be in the middle. 2 and 1/3 times 5 over 5 is the same as saying 2 and 1/3 times 1, or just 2 and 1/3 by itself. And then my largest product is going to be 2 and 1/3 times 6/5, because that's like 1 and 1/5. It's greater than 1. So I'm not only taking the whole 2 and 1/3, but then an extra 1/5 of it on top of that. So that's going to be my largest product. Okay, also be careful when you're doing these. These were all least to greatest, but we all know they can sometimes turn it around and ask you for greatest to least. So when you get to that section in your practice buddy, or a question that asks you to put them in order, make sure you read those directions carefully and you know which way you're supposed to go. Okay, that is it for today's lesson. Generalizations: if you're multiplying by less than 1, your product is going to be less than what you started with. Greater than 1, your product is going to be greater than what you started with. And if you have one of those fractions where the top and the bottom are the same, equal to 1, your product will stay exactly the same as what you started with. That's all you need to know for today's lesson. You can look back at lesson 8.8 on 499 to 504, either online or in your book if you want to review that a little bit more, and then you have your practice buddy to try it out and see if you can do it on your own. I will see you again in a couple of days. Enjoy your work and enjoy field day on Friday.